This is Space News for the month of November 2020, brought to you by the Multimedia Learning Center at Frostburg State University. Our first story updates astronomers' predictions for the prevalence of potentially habitable planets. Using data from the Kepler Space Telescope and the Gaia mission, a team of astronomers predict that about half of the Sun-like stars in our Milky Way galaxy contain rocky, Earth-like planets in the habitable zone. The habitable zone is the distance from a star where liquid water is possible on the surface. This means that there could be about 300 million potentially habitable planets orbiting stars like our own. From this, they determined that the closest habitable planet is likely to be, at most, only 20 light-years away, which is well within our galactic neighborhood. The Blue Ring Nebula looks like a blue blob surrounded by a ring with a star at its center. Its origin has eluded astronomers since its discovery in 2004. Cutting-edge models and an abundance of data have led astronomers to believe that it is likely the remnant of the youngest known stellar collision. Nearing the end of its life, a sun-like star began to swell. This caused the smaller companion star to spiral inward towards the larger sun-like star. The larger star tore the smaller one apart, creating a ring of debris before the sun-like star swallowed the smaller one. The leftover cloud of glowing gas is sliced in two by the ring of debris. A likely explanation for at least some fast radio bursts has been identified in our own Milky Way galaxy. Fast radio bursts, on average, release as much energy in a millisecond as the Sun does in 3 days. Their origin has been hard to determine since their discovery in 2007, because most appear to originate outside of our galaxy, and most have yet to repeat. But astronomers found the origin of one of the bursts to be a magnetar in the Milky Way. Magnetars are a type of dead star, a neutron star, that have a very powerful magnetic field. The great amount of energy released is likely related to the enormous amount of energy stored in the magnetar's magnetic field. The details of how a magnetar produces a fast radio burst are still being worked out. Those are the stories that caught our attention this month. This is Dr. Jason Spates, wishing everyone clear skies.